Well, hello guys, here Mr. G with another question for the grade 12. This time we're going to be doing a question on power, which is question 6 from the mid-year diagnostic exam developed by Professor Rodriguez in 2023. This question says water needs to be pumped from a 30 meters depth borehole. A pump left 300 kilograms of water every minute. The speed at which the water is ejected is 5,0 meters per second. Define power in word. And guys, to do that one, we're going to go to the formulas, and I want you to look here is the formula for power, and so that is the definition for power. Now if we come here, the formula is power equal to work done per unit time. So how do we read this one for definition? We are going to read as rate at which work is done or energy is expended. This one is the definition for power. Calculate the work done by the pump. Now, this is it's an easy question, but it could be tricky. Now, we need to know that the mass of water that is being left up is 300 kilograms. There is 300. For instance, I saw 30. We need to know that the speed at which this water is moving up, speed of the water is going to be 5 meters per second. Now, this is 5 meters per second when it reaches the pump, whatever pump we're working about. So in this case, this one is going to be the final speed. This one is the final speed. You need to know that the initial speed of the water is equal to 0, because that is when the water is going to be right at the bottom in the borehole. Okay, so that is important. And the height from which the water is going to be pumped is going to be 30 meters. Okay, so this is the data we have to be having in consideration. So what are we going to be doing here? What formula are we going to be using here? For this question, we are going to be using the law of conservation of energy. In other words, is the work done by the non-conservative forces. This one says that is equal to the change in kinetic energy plus the change in potential energy. Let's fix this one here. Change in potential energy. And this work done by the non-conservative forces is going to be the work done by the pump. That is the work done by the pump. So if we go further with this formula, the work done by the non-conservative forces is equal to change in kinetic energy is final kinetic energy, which is half mass multiplied by the final speed square minus half mass initial speed square, plus change in potential energy, mass, acceleration due to gravity, final height minus mass, acceleration due to gravity, initial height. Now, how I want you to picture this one here, because it is a little bit tricky to understand. Now, I want to see this one is going to be the borehole, and there is inside water. But let's imagine the water is going to be like a bucket of water that this pump is going to pull up. For instance, there's going to be 300 kilograms of water that is going to be pulled up, and it's going to be very fast. It's going to be 300 kilograms of water every 1 minute. So this one is going to be pulled up by the pump, and let's imagine this pump is like a rope, like is being pulled up. This is the force from pump. Now this one is not exactly like this. Please don't get confused. This is, I want you to picture what is actually happening. So this pump, which is going to be this black arrow here, is going to be pulling this bucket of water of 300 kilograms every 1 minute over a height of 30 meters high. So if we set here, this is at the bottom of the borehole, and it's going to be pulled up all the way to 30 meters. This is going to be the height. The height is 30 meters. Alright, so if the initial height is at the bottom here is 0, the final height is going to be the 30 meters right at the top here. So this one is for you to get an idea of what is actually happening here. I want you to understand. This is a little bit tricky to understand. It's tricky to picture. So the work done by the non-conservative forces is equal to half. The mass is 300. The final speed is the 5 meters per second. It reached this water starting from 0. The initial speed is 0. And when it reached this point here on top, the velocity or the speed there is equal to 5 meters per second. Multiplied by 5 meters per second to the power 2 minus half 300. The initial speed is 0 to the power 2. Everything plus the mass, which is 300, multiplied by 9,8, multiplied by the final height, which is 30. All right, let's move everything to the left, minus the initial height, which is, or the initial potential energy, which is 300, multiplied by 9,8, multiplied by 0. Guys, you can see here that this one is 0, as well as this one is 0. So what we have left? So we have that the work done by the non-conservative forces is equal to 3,750, which is this answer here, plus 82,000 or 88,200. When you add that one, you get that the final answer is going to be 91,950 joules. That is the answer for the work done by the pump to pull that amount of water up. It's not that bad, but this is a little bit tricky to picture that water borehole and so on. Final question 6.3. Calculate the power required by the electric pump to pump that water in the above mentioned rate. Guys, now we're going to use the definition, and we can do it on this side. Power is equal to work done divided by the time. They ask you about that specific rate. The work is what we did calculate just now, which is 91,950. Here we are. I just want to make sure, yes. Divided by the time. The time they give you is every minute. Let's look for that. Every minute, here it is. We cannot work in minutes, we work in seconds. 1 minute half 60 seconds. So when you calculate that one, so the power is going to be 1,532,5 watt. Guys, this is the end of this question. It's very short. I hope it helped. It's not common to have questions of power on the exam, so it could be asked in this exam. But thank you for watching. Thumb up if you understand. Subscribe for the channel. I'll see you next time. Mr. G here.